Hello, everyone. Welcome to today's lecture. Could you hear me? Okay, great. In today's lecture, we will to talk about the structured program. We talked it in last lecture, and also we'll introduce more the program control techniques. And before today's lectures, I would like to tell you some question Q&A sessions for answer your questions timely. And this is our informations for the instructors in this lecture. And me, and then the Peng Fei, and he has gave the first lecture, or the first tutorial. And then the Qian, she gave the last tutorial in the last week, in this week. And finally, the Yu, and he will introduce the tutorial in the next week. And there are our our working email addresses. And also, I noticed that some of you and many of you ask the questions through the emails to us. So, in order to answer your question timely, you can send your questions to all the teaching assistants, to all the tutorials, and also CC your questions to me during the office hours. And also remember to send your questions to our working email listed in the last slides. And if not, your questions may be missed and cannot be responded timely. And finally, you need to clearly describe the questions, your questions with the code or figure, which includes the whole code. And finally, it seems that some questions has been addressed in our lectures and the tutorials. So you can first revisit the recordings after the lecture before you answer the questions to us. Of course, you have any questions, you can send the email to us. But remember, with those clean descriptions and to write the email addresses. Do you have any questions for send the questions to send your questions to our emails? Yeah, if not, we will continue our lectures for the programming control. Yeah, you can see, you can revisit the recording. I will also update the slides into our Blackboard. Okay. Okay. In last lecture, we have talked about the while statement, and we will start from the counter-controlled iterations, which is also based on the while statement. The students and the algorithms for solving this problem on a computer must input. Next, we will introduce the counter-controlled iterations. And this technique uses variables called a counter to specify the number of times a set of statements should be executed. And the counter-controlled iteration is often called the definite iteration because the number of the iterations is known before the loop begins executing. And to show how the algorithms are developed, we will solve several versions of the class average problem. And consider the following problem statement. A class of 10 students they take a quiz, and the grades, the integers in the range from the 0 to the 100 for this quiz are available to you, and the determiner, you should to determine the class averages on this quiz. And the class average is equal to the sum of the grades divided by the number of the students. And the algorithms for solving this problem on a computer must input each of the grades, perform the average calculations, and print the results. Let's say the pseudocode to list the actions to execute and specify the order in which those actions should execute. In these examples, the iteration stops when the counter largest than greater than the 10, and we show how the pseudocode algorithms are development. The algorithms mentioned a total and a counter, and a total is a variable used to accumulate the sum of the values, and the counter is a variable used to count, and in this case to count the number of the grades entered, and then it will int the while interactions, and each time it will re-input the grade, and then add the grade into the value of the total, and meanwhile add the 1 to the grade counter, which means that we have count the this grade for this person, and after the grade counter is greater than 10, then we will leave this while. We'll stop this while iterations, and finally we will calculate the average by the total divided by the 10, and finally we can print the class average. This is the C code for the correspond to the pseudocode of for the problem of the class average problem, and we first type this code in IDE and execute it. First, we type this code in our IDEs. First, we need to define and define the counter. Because the number of the counter is because the value of the counter is always positive, so we use the unsigned int to define to represent the type of the variable counter. Then we'll define the grade, the total, and the average. We need to assign the 0 to the total, because we use the total to calculate the total value of those grades. So at the beginning, the total should be a 0. Also, the counter could be the 1, because we need to input the first grade from the user. And while the counter is less or equal than 10, which means that the grades has not been inputted. All the grades has not been inputted. So we need to read this grade again. Use this while statement. And in the body of this slide, this while statement, we need first to print a message to the user and ask the user to enter the grade at this time. And also we can read this grade. Note that we have defined and declared the variable grade before this while statement. and we should increment total by the value of the grade we read at this time. Same as the total variables, we need to count. We need to increment the count by the 1 because we have read this grade. So this is the whole code of this while statement. And after we read all the grades, the 10 grades, we need to calculate the average of the 10. The percentage sign is means the string, which means the messages we need to print to the screen. Also, we can replace this sentence as the puts enter the grades. We learn the printf and the puts before. So these two statements are both okay in this case. We just comment this line. And now we can calculate the average. Finally, we print the average. And also the percent sign D means the integer type we need to print. So let's run this code. It will ask the user to enter the grade. I just put those grade one by one. We can see the answer here. And in fact, that we can think about that the average for a program, average for 10 integer numbers will not always be the integer, right? It may be the real number. But however, because we use the integer divisions here, so we can only get the integer type the results of the average. And in the next cases, we will see how can we get real numbers from the divisions between the integer numbers. We will see the examples later. So for now, do you have any questions for this program? Yes, why the counter is assigned by the 1 at the beginning? Because at the beginning we will see that now we need to read the first grade, and the counter will represent that now we need to read the first grade in those grades. Also, we can use the 0 here, right? Which will mean that we have not read any grade. In these cases, we need to change this list and equal to the list. And those two different versions will guarantee that we read 10 grades. What's different of using the percent sign is or not in the printf? Sorry, I do not clearly understand your questions about the percentage sign is. You try to delete the when using the print for and yes, in these cases you can only print the messages, which means you can only print the word. You can only print messages as the string type. However, you cannot print the other format. Print the messages in other formats. So as a good practice for the programmers, we will always add this string format in the printful statements. Other formats such as please and like this, you can add other informations or the %d to end the yes, you can print the %d and then you can add a value of this integer. So the printful and the scanful can read the informations in the defined formats. If you just input the messages, they are the difference. However, you will print for other formats, such as printful, the %d, and then the grade. And the something like this. Yes, the is in means the string. However, in the C language, we will not use the string. We'll use array of the characters to represent a string, and we will introduce it in the future lecture. So, do you have any more questions about this examples? To print the messages in the standard output, and usually the standard output is our screen. Okay, we will continue for the next example. Now we go through this code again and explain some parts of some important statements of this code. First, the algorithm mentions a total and a counter, and a total is a variable used to accumulate the sum of the series of the values, and a counter is a variable used to count. In this case, to count the number of the grades entered. And because the counter value is used to count from the 1 to 10 in this program, they are all the positive value. So we declined the variables as an unsigned int, which can store only the non-negative values. That is 0 and the higher value. And the variables used to store the totals should be normally be initialized to 0 before being used in a program. Otherwise, the sum would include the previous value stored in the total's memory locations. We cannot guarantee the value of the total is 0 if we do not assign the 0 to the total. And the count values are normally initialized to 0 or 1, depending on their use. We will see the difference of them. and later, and an uninitial value will consist of garbage value, and the value not stored in the memory locations reserved for that value. So if a counter or total isn't initialized, the results of your program will probably be incorrect. And then this is the while statement, the while statement block. First, if the count is less or equal to 10, we can enter the grade, we can ask the user to enter grade. Then we read the grade from the user. And then we will add the total, the grade at this time to the total, and also add the and run to the counter, which will count the number we have read for the grade. And next, we will the average calculations in the program produce and then we will divide it by the 10 to get the value of the average. Finally, we print this value. And in these cases, the average calculations in a program produce an integer result of the 81. Actually, the sum of the grades in this example is 81.6, which when divided by 10, usually is 81.6, which is a number with a point. And we will see how to deal with such numbers, and which we have learned this number, the foreign point numbers, in the next section. Let's generalize the cross-averaging problem and consider. Notice that in the last examples, in the counter-controlled iterations, we have known the number of the grades before we write this code. So we have already known the number of the iterations before we write the code. So we can use the counter is less than 10 or less than 10 to decline these conditions for the while statement. However, in some cases, we will not know the number of the grades or how many numbers the user will input. So we cannot use the statements like this. We cannot use the controlled iterations. And in this case, now we'll introduce how to generalize this class average problem if we do not know the number of the grades before we write this code. Following problems, develop a class average problem that will process a arbitrary number of grades each time the program is run. And in the first class average examples, the number of the grades 10 was flowing in advance. And in this example, the program must process an arbitrary number of grades. How can the program determine when to stop the input of the grades? And how will it know when to calculate and print the class average? And one way to solve this problem is to use a spatial value called a century value, also called a sign value, and dummy variable value, and or a flag value to indicate the end of the data entry. And the user types in grades until all the grades has been entered. The user then types the flag value to indicate the last grade has been entered. And this control iterations is often called the indefinite iterations because the number of the iterations isn't known before the loop begins executing. And because the grades on a quiz are normally non-negative integers, and so the -1 is an accepted value for this problem. Since a run of the class average problem might be processed a string of the inputs such as the 94, 96, the 74, and the 70, and the 98, and then finally we'll input the -1. The program would then compute and print the class average for the grades. And the pseudocode statement initially total statement initially total to 0 and initialize the counter to. This is the C code. The program corresponds to the pseudocode we have seen at the last slide, and we will first type this code in our IDE and then explain some important parts in this code. This code. Now we first type this code in our IDEs to see how the central controlled iterations works. First, we also have the counter, and then we also have the grade, the total, and the average, the values. At this time, we will define the type of the average, be the float, instead of the int. So we make the average, the variables can be stored the real number. Also, we will initialize the total and the counter as 0. And now we'll tell the user that the user need to input some grades, and also tell he or she that if you input a -1, then the code, the input, then it will represent that the input is finished. So we will first print for the message to the user. And then we read the first grade from the user. And while this grade is not equal to -1, yes, why the float, the header is not typed it? Because if we use some calculations for the float type, then we can include the float header before the main functions. However, in these cases, we do not to include some special calculations for the float for the float variables. So we do not include this header, the header. Yes, if you do not use the float, you don't need to include it, because we just use some simplest calculations, and the most simplest calculations for the float has already been included in the C compilers. In some complex cases, for this float calculations, we need to include this header. Yes, it will give the same results. Yes, in UUnit, you do not need to include the float header because you will not using some complex operators for the float. Right now, for the programs you learned, you do not include this header. And we will tell in which case we need to include it. And in this case, we can not include this. Yes, you can choose the other flag values as other values. Yes, you can use your own flag value. However, in our general cases, we usually use the -1. Yes, not in this lecture. So you can use other values to define the flag value. However, usually we will use the -1 as this flag value, and this is the rules, some rules for the programmers, so they will know that -1 is the flag value. So other one who read your code, it also can know this -1 is a flag value. It's like some common rulers. Of course, you use some other value, you can also get the correct answer. And if in your assignment or the examinations you use the other values, you can also get the full scores. So we need to change this condition. And in the last examples, we use the conditions. The counter is less than or equal to 10. And in these cases, we need to change the condition as the grade is not equal to the -1. And also, we first to calculate the total and the counter. Because we have read the grade before for the first time, in the first time, so we can just add its value to the total before we read the next grade. Also, we need to ask the user to print the next grade. On the -1 to end is a message to user and to tell the user that if you input the -1, then which means that your input is finished. So it's just a flag to give the user. And also, we will not count the -1, which just like a flag. And this flag is to tell the user that if you input the -1, and then you tell me, you tell the program, you tell the code that you have input all the values, all the grades. Yes, it's a signal. Different from the first examples, we just divide the total by 10. In this case, we need to check whether the counter is 0, which means if the user do not input any grade, if the user do not input any grade, we cannot calculate the average, right? So we'll add this if statement here. If the count is not equal to 0, we will calculate the value of the average. Also, we need to include the float here, and I will introduce why we need to include this case operators later. The 10 is not the counter in these cases, because we do not know the number of grades. In fact, for this example. So in this example, this counter will storage the number of the grades the user input. Yeah, I will introduce this line later. It's very important. It's very important to see how can we convert integer type into a float type. How do we get the? I will introduce it later. Okay. Yeah, we need to type the total count divided the counter. Yes, and if why we write yes if the user at the first time we ask the user to input a grade, right, and the user input the -1. In this case, no grade, no valid grade will be input from the user. And in this case, the counter will be 0. So we cannot divide a number by a 0. So we must include this line. It's very important. When you write your own programs, remember, if you write this division operators, remember the number which is divided by should not be 0. Yes, we do not know how many times we will iterations, and we do not know how many grades will be input from the user. So this is different from the counter-controlled iterations. Else, which means that no grades is input by the user from the user. So we should say that no grades will enter. Also, we can not use the %d. Remember, the percent sign d means the integer number. However, the average is not an integer type. So we use the %f. And also we use the .2. And I will explain why we need to use the .2 here. What's the difference between the puts and the print4? I remember we talked about this problem in the last lectures. And the puts means that we need to output messages, and we can only output the messages with the string. And however, the printf can print many values in different types and in different formats. Okay, let's run this code. Sorry, I missed. So, such as I input the 2 and the 3, and I input the -1, and we can get the grades, right grades, and it is a real number. So let's see if at the beginning we input the first grade is a -1, and it will show that no grades will enter it. So this is very important. If we do not include this if conditions, we will get an error from this. We will get an error when we run this program. For example, we comment those 9. And just calculate the average and print. If we print the 2, the 3, and -1, it will get the right answer. However, if we enter -1 at the beginning, then it will be a none. Well, it will tell us that the average is a none, which means a non-number, not a number. So remember to include this if sentence in your all programs when you're using this division operator. Next, we will explain this case operators and this format. It was noted that in the while loop, here from the 9 in a while loop, here, the braces are necessary to ensure that all the 4 statements execute within the loop, and without the braces, the last 3 statements from the 926 to, which means that if we do not use the brace here, we move this brace to this 9, what will happen? If we put the wrong places for this brace, we will have some problems. So, which problems we will face if we move this brace to this 9, follow this statement? And you can try to stimulate the process, how the program executes. So, which means that if I input the 2 at the first time, and then I read the 2 here, right? The value 2 for a grade here. And Of course, the grade will not equal to -1 because we input the 2. So the total will be added by 2, and the counter will be added by 1. And it will check the condition again. Because we do not change the value of the grade, because we do not read a new grade from the user. So the grade is still 2, right? And this condition is also true in the second case. So we run this code again and again. Yes, the Zhekai and the Wen has get the right answers. If we do not read the new grade inside the while loop, then the while loop will not stop it. So our program and this code is always run and cannot be stopped. For example, we can, yes, we run it. And in order to make you to see the real cases, I will print a number here to verify that the loop is really run again and again. Such as I print the counter, right? And now I will run this program. The computer will not be broken. You can stop this program. For example, I input 2 for the first grade. Then the counter has become larger and larger, and I should include a new 9 so you can see the. Then I have to stop this program. Okay, I input 2. So it always in the while loop. And the counter becomes larger and larger. And it will not be stopped if it will not be stopped in case I stop this program or I close this IDE. So when you write a program which includes some iterations, you should double check where this loop will stop and how and the conditions, and if the conditions can really be false in some cases. Do you have any questions for this loop? Okay, let's continue.
Line 30, the last 3 statements in the body of the loop would be outside of the loop, which will lead to accusing the computer to interpret this code incorrectly as follows. And this would cause an infinity loop if the -1 is not input as the first grade. We can see, we can type this new situations in the C IDEs. Let's see whether this loop will not stop. In code, and we have 20 code, and we have seen this statement in our code. We add a float in front of the total, but why we need to add this float in front of the variable of the total? The averages do not always evaluate to the integer values. Often, an average is a value such as 7.2 or the 3.5 that contains a fractional part. And those values are referred to as floating point numbers and can be represented by the data type float. And so, the variables of average is defined to be a type of the float to capture the fractional results of our calculations at the beginning of this code. And however, the results of the calculations, the right part, if we remove the float part, then it will become the.
So now we talk about this statement. If we remove the float, the case operators, what will happen?
Total division counter. So the results of the calculations of the total division counter is an integer, because the total and the counter are both the integer. Dividing the two integers results in an integer division in which any fractional part of the calculations is lost. And because the calculations is performed first, we have introduced it before. For these expressions, we will first calculate the right part of these expressions and then assign the value of the right part to the left variables, the average. So because the calculations is performed first, the right calculations, and the fractional part is lost before the result is assigned to the average. And to produce a floating point calculations with the integer values, we must create
So do you have any questions for this first statement? Why, even we define the average as a float type, we cannot get a really real numbers for these expressions for the value of the average? Do you have any questions for this case? In fact, that's right. And let's see the result. Okay. For example, if I remove this float before the total, then it will be like this statement, right? So if we input the 2 and the 3, and then the Q1, however, we get the value of the average is 2. It's not correct, right? Because it should be the 2.5. So the reason is that if we see this statement, it has two operators, this divisions and this assignment operator we have seen before. And we have introduced that the division operator should be calculated first before the assigned operators. So we need to first calculate the right part of this statement, right? So the total is an integer, and the counter is also an integer. So this division will be the integer division. And the total divided by the counter will be integer type, the value. So we get the 2 here. Even we get a 2 here, and then we assign the 2 to the average. So we get a real number of the 2 integer. So we get this value here. Do you have any questions for this part? Then it will be a great answer. It will have the right answer, and you will see the case in the next statement. I will explain these situations. If you define the float total in this code, yes, you can define the float and the total and the counter as a float type in this program. However, I use the integer here to show you how to convert a type into another type. This case will help you to know what had happened before the type conversion. If the counter is a float and the total is an integer, then you will get the right answer. I will explain it in here. So in this case, if we remove this float, we get a wrong answer. Do you have any questions for this step? Because some of the beginners, they are very confused. I have defined the average as a float type. Why I get a wrong answer? Because we need to calculate the expressions at the right part first. And then in these calculations, the fractional part has already been lost. Yes, if you write an int instead of a float, then you can convert averages into an int type. Yes, it will also be okay if you change the float in the front of the counter. If I will explain it later, and then you will know what happened during this float cost operator. So in the first case, do you have any questions for the wrong answer if we write the code like this? If no, we will introduce the case operator.
That are the floating types numbers. And C language provides the cost per operators to accomplish this task. We can see the statement, which includes the cost operator, the float, which will in front of the total. And this cost operators will create a floating point copy of its operands, the total. And the value are stored in total is still the integers. We just will create a copy of the integers of the total, of the variable total. So using a cost operators in this menu is called the explicitly conversion, because we explicitly use a float in front of the total. And the calculation now will consist of the float point value divided by the unsigned in.
So these cost operators will create variables. We do not know the name of the variable, which is a copy of the total. However, its type is a float. So we will use this new created variables to calculate the divisions operator to calculate the division. However, the value in the total is still integer type. So here we create a new variables, which is a copy of total. However, the total is still total. It's still the integer type. So after we use this, we will use the new created variables to conclude this calculations. So the type will be like the float is divided by an unsigned int right now.
Value stored in this counter. And C, however, the C can only evaluate the expressions in which the data type of the operands are the same. So, however, in this case, the left part of the operator, the division is a float, and the right part is unsigned int. So it cannot calculate the results of them directly. However, to make sure the operands are the same type, the compiler, the C compiler, will perform operations called the implicit conversations on the selected operands. And for example, in expressions which contains some data types unsigned int and the float, it will copy the unsigned int operands to the int to results of the floating point type with a float type will convert the unsigned int to the float type. And in our examples, after a copy of the counter is made and converted to the float, and then the calculations is performed, and the result of the floating point divisions is assigned to the average. Also, C provides a set of zoners for conversations for conversion of the operands of different types. And we will discuss those different conversions in the future courses.
So, do you have any questions for these cost operators? In fact, these cost operators can only help us to convert these forms into this this float divided by the unsigned int type. And then the compiler, the C compiler, will help us to do another conversations, which will further convert the unsigned int type into a float type. So we can get the right answer. Do you have any questions for this operator? In fact, we do two things here. The first is create a new variables, which is a copy of total, and its type is a float. And then the compiler will do a second step. It will convert the unsigned int type into the float type. Yes, if we can add a float in front of counter, and also we can add both the float before the two variables, which means that we can remove this float here, right? If we remove here, then it will first convert the counter into create a copy of the counter as a float type, and then it will do a second type to convert the total, the integer type of the total into a float. Also, we can do something like that. We convert two, we explicitly conversations, the explicit conversations for the two variables. However, if we use two floats in front, there's two variables, then we will create two new variables. It will waste the space in the computer, the memory. Yes, the compiler will do not do the implemented conversations. However, it will waste some memory. In fact, the C compilers can only use the divisions operators for two variables whose type is same. So if we use a float to divide it by an int type, the compilers cannot do these calculations, so it will convert the int type into the float type. So it must convert. The float is not convert. You need to remember that the float do not really convert the total into a float type. It just create a new variables, which is a copy of the total, which has the same value as the total. However, this new variable's type is a float. So the total is still the total. In the calculations, it will convert the type, and in order to get the right calculations. However, the variables, the total and the counter is still their original types. It not convert any variables. It just create a new variables for the total. For total itself. If we use two floats in front of two variables, then it will get two copies of these two variables respectively. No, this case it can get the right answer because it has two steps. The first step is that it will see here, it will create a copy of the total. And then the compiler will do another conversion. The compiler will find that, oh, now it's the float is divided by unsigned int. So the compiler will then do a implicitly converts to convert the unsigned int to the float type. Even we just use one cost operators here, however, in fact, two steps are executed. Yes, here, in the first step, it will not create a new variable for the counter. And in the second step, the C compiler will convert where a copy of the counter is made and converted into the float. It's two different things. If you use this cost operator, the computers will help us to do it. If the computers find that there are two different types for the division operator, then it will automatically to convert one type to assign to align to another type. So we ask the computer to convert at the first time, also at the first step. Then the compiler will automatically to convert another in the second step. However, if we remove this float, then these two variables are int type. So this will be a division, the int division, integer division. Right. Do you have any questions for this? conversion. Yes, if we do the total, we only include the float in front of the counter, then we will get the correct answer. Why? First step, it will get a copy of the counter, which is type of float. And the second, the compiler will automatically create a copy of the total whose type is the float. So the conversations, the order of the conversations is different if we insert the float in front of the counter. They have the similar process, but the process are different. In fact, you can just define the counter and the total as a float type at the beginning. However, in order to show you and make you understand how the conversation is executed and how the conversation is performed, so I used these examples. If a float the cost operators in front of a variable, and then it will get a copy of this variable. For example, in this case, first we will have the int, and then after we add the float in front of the total, and then the type will become the float divided by the integer, the int. So the one float is for one variable. The other variables is performed automatically by the compiler.
Also, we have seen at our code, we use this string format to identify the print format, the format for the printing. And we use this, the print for conversation.
Now we talk about the print format for the real number here.
Specifier the percentage point to f to print the value of the average. First, the if, which specifies that a print point value would be print, like the percentage d. The d means the integer type we have seen at the first lecture. And also, we can say we have the dot 2 in this format, which means that the point 2 is a positions in which the value will be displayed. So the 2 digits to the right of the point will be displayed. If we do not include this dot 2, then the default number of the default digits to the right of the point will be 6.
So it means that the 2 means that we will print the 2 digits followed this dot. And if we remove this 2, the default digits will be the 6. Yes, if you want to keep the 3 digits in your output, it depends on you yourself, or depends on the sorry, will depends on the runners of this problem. Sorry. Of course, you can use the 1. Then you will get the 1 numbers followed this dot. This is the runners for the C compilers for the print4 functions. If you do not include any numbers, then it will print the 6 digits. It's just the runners in the print4 function. We'll write this compiler.
And we have seen the control statement may be static on top of one another. We just as a chart statement built-in blocks in a sequence. We use multiple if-else statement and stack them. And in these cases, we will see the only other structured way control statements may be connected in C, which means we may state the if statement in the while statement, which is namely through the listing of one control statement within another. First, we will give the results of we will give the examples. And in a class of the 10 students, then get the results of the students from the user. We will get the results from those from the user. And the 1 means the pass, and the 2 means the failed. And we need to find the number of the students who failed and who passed. So if more than 8 students passed this course, we will print a statement for the for bounders to the instructors. And after reading the problem statement carefully, we make the following findings. First, the program must process the 10 test results. So a counter-controlled loop will be used. And the second, each test result is a number, either a 1 or a 2. So each time the program will read a test results, and the program must determine whether the number is 1 or 2. And we test for 1 in our algorithms. If the number is not a 1, we assume that it's a 2. And third, we need to have 2 counters. We need to use 2 counters. And the first counter is to count the number of students who passed the examiner, and also one to count the number of students who failed the examiners. And finally, we need to print something. After the program has processed all the results, it must decide whether more than 8 students passed the examination. Here.
So, do you want to try to solve this problem? Use the while statement and the if statement, or I just give you the answer and the pseudocode and its corresponding C code. Do you want to try to solve this problem using the C language by yourself? Yes, maybe I give you 5 minutes and you can first try these problems. The hint is that you can implement the functions using the while and the if statements. Do you finish the code or finish the core blocks of this code of this problem? Okay, maybe 2 minutes more. You have just 2 digitals and using the default print format. We should continue the lecture, and if you are not if you do not finish the whole code, you may first follow me to see the code first, and then try it again after this lecture.
Must process the 10 test results. So a counter-controlled loop will be used. And the second, each test result is a number, either a 1 or a 2. So each time the program will read a test results, and the program must determine whether the number is 1 or 2. And we test for 1 in our algorithms. If the number is not a 1, we assume that it's a 2. And third, we need to have 2 counters. We need to use 2 counters. And the first counter is to count the number of students who passed the examiner. And also one to count the number of students who failed the examiners. And finally, we need to print something. After the program has processed all the results, it must decide whether more than 8 students passed the examination. Here is the schedule code of this problem. First, we will initialize the passes to 0, which is the pass counter. And also we need to initialize the fail to the 0, which is count the number of the fail test. And also we need to initial the student to 1, which is count the number of the student we have read from the data. Also, and here is the counter control iterations. While the student's counter is less than or equal to 10, then we will input the next examiner results. And if the student pass the examiner, we will add 1 to the pass, else we will add 1 to the failed. So after the if statement, we need to add 1 to the student counter, which means that we have seen the this exam result from the students. And finally, we outside the while loop will print the number of the passes, print the number of the failed cases. And if more than 8 students passed, we'll print a message to the instructors. Now we type this code into the IDEs and test the results of it.
First, we'll decline and define 3 variables, and also initialize their value. And because all the 3 variables will be a positive number, so we use unsigned int. And while the student is less or equal to 10, because we initialize the students as 1, so we need to use less than or equal to. If we assign the students as 0, so we can just use less than. And I see the one has used initialize the students as 0. So the 2 cases are all the 2 versions are all correct. And in fact, you can also use 10 as initialize of students and 10, and then change the value as 20. However, if we usually start from 0 or 1. And in fact, we usually use 0 and to initialize the students, because in the computer world, and everything starts from 0, not instead from 1. It's just practice runners. You can choose your all versions based on your preference. And then it will tell us to input. Ask the user to input. And then we read the result. Now we need to use the if statements, because we need to judge whether the student passed this course. So in this example, we will know that the different statements, the structured statements can be listed. Okay, later on. Yes, you are right. We must include this sentence inside the while statement, the body of the while statement. If not, then this counter. If not, then the counter will not be changed during the while statement. Yes, if you do not change the value of the counter, then the counter will always be the 1 at the beginning, at the 9, 10 you defined. So then the while statement will always be true. We will get the infinity loop. Now we input some result for the and we can get the right answer. Yes, you will get the infinite loop because the value of the counter will not be changed. So it will always be the value which is which is in front of the while statement. So do you have any questions for these examples? I see many of you, some of you all get the right code and the answer. And this example tells us that we can list the if statements inside the while statement. Of course, you can use 2 while statements. And if the problem needs you to use 2 while statements. However, in your code, if you use the while statement like this way, you cannot get the correct answer. While. It worked. You do not change the value of the counter in the second while statement. So in the second statement, you cannot return and execute the second while loop. You can try more cases, then your program may get the infinite loop. For example, the first grid is 1 and the counter is 0, and then you cannot execute the second while loop, right? Because the value of the counter will not be changed, and also the grid will not be changed. And this condition is always true if you do not change the value of the counter and the grid. So, do you have any questions for this example? This example tells us we can list it multiple different types of statements, and to achieve some complex functions and to solve more complex problems. I do not think this code can really work. It can work if you input some special cases. However, it cannot pass all the cases. When you test this is a runner or a way to help you to test whether your code is really correct. Is that you can input different inputs, different cases, and to see whether your program can really get the right answers for all the cases. Especially for these cases in some special conditions. For example, in our first example, the second example, the counter is 0 if the user input the -1 as the first grade. For example, our second example, if the user input the -1 as the first grade, if we do not write these if conditions to judge whether the counter is equal to 0, we just just calculate the average by divide the total number and the counter, then we will get the wrong answer. So maybe your programs, your code can pass some special cases. However, when we write a program, we need to pass all the cases. And in this case, your code is really correct. In your assignment or in your examinations, if you just pass a part of the cases and maybe neglect some special cases, you maybe will lost some scores. Next, we will see the assignment operators. In fact, we have seen the assignment operators many times. Each time we assign a value or a number or another value, the value of another variables to a variable, we use the assignment operators. And here we give the clearly definitions of the assignment operator.
In these lectures, we will also learn the assignment operators. We have seen the assignment operators before. We will assignment operators for simplifying the assignment expressions. For example, for these expressions, the C, the total value of the C and the 3 will be assigned to the C. We can simplify these expressions as this format: the C, the plus, the equal, and 3. And these operators, these assignment operators, will add the value of the expressions on the right of the operators to the value of the variables on the left part of the operator, and store the results in the variable on the left of the operators. So in these examples, first we will add the value of the expressions, add the values of the right part 3 to the value of the variables of the left part, the C, and then store the value of the C and the 3 to the left part, the variable C. So we update the C by adding 3 of it to it. And also there are other assignment operators. We can use the negative equal, the star equal, the division equal, and the percent sign equal. They have the similar rulers. So could you guess the answer of those expressions? What's the way?
Maybe I give you 1 minute and you write an answer for each statement. Yes, the answer for the 5 operators on this slide. In fact, the answer has been showing on the rightmost corner here. Yes, you are correct. There is no space between these 2 signs. There is no space between those 2 signs.
To the C, D, E, F, G after these expressions. The answer of the C, D, E, F, G, the value of those different variables. C also provides some other operators, such as the increment operators, the plus plus, and the decrement operators, the negative sign. And if a variable C is to be incremented by 1, then the increment operators, the plus plus, can be used rather than the expressions, the C, the value of the C added, the total value of the C and the 1 to be assigned to the variable C.
So I will put, I will type this code in our IDEs, and you can guess the answer for each output. What results will be output on the screen. Remember, there are different for the pre-increment and the post-increment operators. They are different. So you will have different answers in these 3 lines, and these 3 lines will have just these 3 lines will have different answers. It's very important to make clearly the difference between the pre-increment and the post-increment based on their definition. could you guess the answer for this 6 outputs? Do not type the code in your OIDE, just guess the answer. And based on your understanding for the definitions of the pre and post increment. Yeah, I see you may have different answers. Now I run this code to see. The answer are showing here, 556566. Why? So this is caused by the difference of the pre and the post increment, and the answer also showing here under the comment. First, in the first line, we will print 5 because the C is 5, right? And at this line, this is the post increment, which means that the C, the expressions of the whole, the expressions of the post increment will be the original value of the C, and so it will print 5 here. And however, after these statements, the C has been increased by 1. So the value of the C has become 6. So when we print the new value of the C, it's 6. And in this case, we reassign the C as 5. And the first line we print 5 because the value of the C is 5, right? And now we use the pre-increment operator, which means that in this case, the C will be increment by 1, and the value of the expressions will be the new value of the C. So now we'll print 6 here. So remember the difference between the pre and the post operators. The pre-increment is that increment by 1, and then use the new value of the variable in the expressions in which the variable is resides. And also, however, the post increment operator is that use the current value of the A, the original value of the A in the expressions, and then increase the C, the variable, by 1. This sign N means that the new 9. Thanks to Akai to explain the meaning of this sign. Sorry, I don't know what you're meaning for y type 2 new lines.
How?
That's not floating. We just use one. Why? This is the definition, how to use this sign. Yes, it will input another new line to specify those two different cases. If you add this, then those three outputs will be separated. Yes. For distinguish those two cases, so add a new line here. Here, we summarize some operators and their per sentence and social activities for these operators. And you can, when you write your own code, your own programs, you can check these operators to make sure you write the statements as you want. Okay, we will continue our lectures to learn more program control techniques for the iterations and the selections. We have learned the iterations, we have introduced it before. Maybe you can find the recording of the lecture too. Also, to make the iteration statements to execute the statements repeatedly, and also to understand the multiple selection using the switch selection statements, and finally to use the break and the continue statement to alert the flow of the control. First, we will introduce the 4 iteration statements, and this is an example of the controlled. This is the general format of the 4 interaction statements. And for this example, when the 4 statements begins executing, the control variable count is initialized to the 1. And then the loop continuation condition counter is less or equal to 10 is checked. And because the initial value of the counter is 1, so the condition is satisfied, and so the print statement will print the value of the counter, namely 1. And also the control variable counter is then incremented by the expressions, the increment of the control variable count, and the loop begins again with the loop continuation test.
And because the control variable is now equal to 2, and the final value is not executed, so the program will perform the print statement again. And this process continues until the control variable counter is incremented to its final value of the 11. This is caused the loop continuation test to fail, so the iteration will stop. And the program continues by performing the first statements after the 4 statements, in this case, the end of the program. And this figure takes a close look at the 4 statement of this example. Notice that the 4 statements does it all. It specifies each of the items need to be the counter-controlled iterations with a control variable. And there is more than one statement in the body of the 4. Braces are required to define the body of the loop. And this is the general format of 4 statements, and where the initialization expressions will initialize the loop control variable and maybe defined, and also maybe will define it. And the control expressions, the condition expressions is a loop continuation conditions, and the increment expressions will increment the control variable. And also, often the initialization and the increment expressions are the common separated list of the expressions. The 4 statements is flow charted much like the while statements. And for example, this figure shows the flow chart of the 4 statements for the last example. And this flow chart makes it clean that the initialize will appear only once, and then the incrementing will be executed after the body statement is performed. And also, the 3 expressions in the 4 statements are optional. They are the initialization expressions and the condition expressions and the increment expressions. And those 3 expressions are optional, which means that we can include partial of the 3 expressions in the 4 statements. And also, if the condition expressions is disappeared, then the C language will assume that the condition is true, and it will create an infinity loop. And also, if we remove the initialization expressions, and if the control variables initialize, we can also initialize the control variables elsewhere in the program. And finally, we can also remove the increment expressions. We can calculate the control variables by the statements in the body of the 4 statements. So in this case, the increment appearance expressions is not needed. Here are the 3 examples for the optional head in the 4 statements. And the 3 versions are all valid code for the 4 statements. And the first print 4 statement will be executed infinity. And the infinity loops are used when the loop continuation conditions in a iteration statements never becomes false. So it will execute the infinitely. And the third is removes the initialized statements, and we initialize the I before the 4 statements. And finally, example is that it removes the increment expressions in the 4 statements, and we increase the control variable I in the body of the 4 statements. And a statement, and we
Do you have any questions for the three cases in the four statements? If no, I will continue introduce the four statement.
And increase the control variable I in the body of the.
Yes, the for statement is also a iteration statement, and the while statement is also the iteration statement. So both statements can perform the iteration. However, in for statements, we have included some initializations for the counter values, for the counter variables, and for the counter increment, and something like this. However, in while statement, we need to do those two of those two operators, those two expressions inside the while statement. However, in the for statement, we can just include those initialization and the increment in the header of the for statement. They have the similar functions, however, in different formats.
For statements. And the following expressions shows the methods of varying the control variables in a for statements. It is better to limit the size of the control statement headers to a single line if possible. So now you can, based on those tasks, these different situations, to write the for loop expressions. Maybe I will give you 5 minutes.
Could you write the corresponding for loop statement, the header, for those different tasks? For example, maybe the first loop will be like this. Yes, you also have the correct version. And you decline the variables inside the for header, and we will talk about this later. These different tasks has a similar for loop header. Just they are different in the step and the increasement or the decreasement, right? For example, the last case may be like this. Sorry, I have a typo. So let's continue for the loop, for the for loop.
And the answers are showing here. You can check your answers with this example answers. Examples of the answers. Finally, we have some notes for the four iteration statements. First, the initialization, the loop continuation conditions, and the update expressions can include some arithmetic expressions. For example, if x is given by 2 and y is given by 10, then these two statements here and here are the same, and they are equivalent to the statements for the next statement here. And if the loop condition,
sure, you can use the arithmetic sequence and write the whole sequence instead of the increment and decrement operators. And however, if you use the increment and the decrement operators, then you can simplify this statement. It will be if you use the original arithmetic sequence, then the statements will be longer than this increase and decrease one.
Continuation conditions is initialized false, then the loop body does not execute it. For example, for the last examples, if the I is larger than 10 at the beginning, and then
in fact the initialization and the increase and the decrease statements in the four statements, which I mean the first and the third operands, they can be any forms of the arithmetic expressions.
Loop continuation conditions is initialized false, so we will not enter the for loop body, and the loop body does not execute it. Next, we will introduce the variable declarations in the four statements. The first examples here we're showing here. We
in last examples, the one has used this example instead of the first one. So in the second examples, in fact it includes declarations of the variables. We will introduce it in more detail.
Seen it before. It first define and declaration a variable I and assign 0 to the I, and then in the four statements we just use the variable I and use the I as the control variables in the four statements. And in the second examples, the first expressions in a four statements can be replaced by declarations in a four statements. For example, it's showing besides this box. And this feature allows the programs to declare variables for use by the loop. For example, for the statements are showing here, the variable I need not have been declined before to these statements, we can decline and define the variables inside the for statements. Which means that these examples can be fully replacement by the second one. The variable I need not have been declined before to these statements. We can decline and define the variables inside the for statements. And it's worth noting that a variable declined by a for statement cannot be exercised outside the body of the loop, and which means that we see that it's not visible outside the loop. For example, showing in this code, we can exercise and visit the variables I inside the for loop. However, if we exercise or visit the variable I outside the for statement, then we will get the wrong answers, which means that the variable declined by a for statement cannot be seen, and it's not visible outside the loop. And however, having a for statement decline its own control variables is usually a good idea, and it's convenient, and it can make the programs easily to understand. And however, if the program needs to exercise the variables after the for loop, and then it's necessary to use the older forms of the for statements, which means the last statements we define the control variables before the for loop. Next, we introduce the common operators, and the common operators is often used in the for statements, and its primary use is to enable you to use the multiple initialization or the multiple increment expressions. And a for statement may need to have the two or more initialization expressions, or one that increment several variables each time through the loop. And for example, there may be two control variables in a single for statements that must be initialized and incremented. So this effect then can be accomplished by using a common expressions as the first or the third expressions in the for statements. And a common common expressions often has these forms: the expressions 1, then the common sign, the operators, and then the expression 2. And where the expression 1 and the expression 2 are any two expressions. For example, we can give an example that the two expressions, the x is assigned by 0, and the y is also assigned by the 0. Now we will learn more about the common operators, and the commons are usually here are actually the common operators that guarantee the list of the expressions evaluated from left to right. And the value, and for example, in this case, the first expressions 1 will be evaluated, and then its value will be discarded. And then second, the expression 2 will be evaluated, and then its value will be the value of the whole expressions. And which means that the value and the type of the common separated list of the expressions are the value and the type of the rightmost expressions in the list. And also, evaluating the expression 1 should always have a side effect, which means that if it doesn't, then the expression 1 will serve us no purpose. For example, in this example, if the I and the j are given the value the 1 and 5 respectively, and the value for the whole expression. So if the I and j is given by the 1 and 5,
what's your value for the whole expressions? We have two expressions here, right? The expression is one, the pre-increment of the one, and the second expression is the add operators between the I and j. However, in fact, this is the expressions because we use the common operators to connect multiple expressions. So for this whole expressions, including those two expressions, what's the value of these expressions? Remember, in the common operators that guarantee that list of the expressions evaluate from the left to right, and the value of type of this list of the expressions will be the value and the type of the rightmost expressions in the list. These left expressions will not be put into the right expressions, but the left expressions will change the value of the I, right? It changes the value of the I, and the second the right expressions will use the value of the I, will use the variable I. So it will affect the value of the right expressions, but it does not put into the second expression. So the answer for this common operators listed expressions is 7. Will be 7. Why? First, it will be executed the left expressions. So the I will be assigned by 1. So the value of the I will be the 2 after executing the left expressions. And then it will execute the right expressions of the whole expressions. So we will
increase, the 2 will be increased by 5. So we get the 7 for this rightmost expressions. Also, the value of the whole expressions will be the value of the rightmost expressions. So the value of the whole expressions will be 7. And same as the if statements and the while statement, we can also list the for statements to form the listed for loops. And in these examples, we will print the coordinates in a map from its top left side to the bottom right side based on its coordinates. They are the rows and the columns. Now is your time. You are requested to use the for statement to sum all the even integers from the 2 to the 100. Maybe I will give you 4 minutes to write this code.
To sum all the even integers from the 2 to the 100. Using the for statement. I believe that it is an easy case for you to solve. To list the coordinates from the left top to the bottom right of a map, such as the 0, 0, the 0, 1, and the 0, 2. And then the next row may be the 1, 0, and the 1, 1, like this. From left to right and from top to down. Do you finish this example? This problem sum all the even value numbers from the 2 to the 100. So in these examples, we will start from 2, right? So the counter, the number, will be initialized as 2 in the for statements. And also, the condition is that the number should be less or equal to 100 because we need to add the value do not greater than the 100. And finally, the step for this expression will be 2, right? Because it's an even number. We need to print the sum all the even numbers, the total of those even numbers. Yeah, we just talk about this assignment about 20 minutes ago, maybe 10 minutes ago, which has the same functions for the add operators and the assignment operators. For example, the C is assigned as a C, and 1 will have the same value for this. So now we show the code for these examples. In fact,
they are the example
has the very closer answers and just using just add the different values.
Examples of the code, and in fact, the body of the 4 statements in this figure could actually be merged into the rightmost portion of the for head by using the command statements. In fact, we can move these statements at line 10 to the most right part of the increment expressions by using the common operators. And also the initialize the sum is assigned by 0 could also be merged into the initialization selections of the 4 statements here.
For example, in this case, is also the example for the common operators. We can remove this statement inside to the for head here, right? So it's also a case for the common operators. Can we delete the first equal to 0? This is for the sum, right? This is the number for the sum. If yeah, it's the sum, not the number. Yeah, the percentage sign U is to print the unsigned int type value. And also the percentage D will print the integer type. So we can also simplify these statements into this form.
And I show the results here. We can merge the statements and initialize into the for head of the 4 statements. This is other examples, and you can first go through these questions, consult the following problem statements, and then write write a program using the for loop that performs the indicated calculations for each of the 10 years. The money will remain on the deposit.
This is the other examples to use the for statement to account the comment in interesting calculations. We may move these examples into the tutorial in the next week. So now we just skip this example.
Loop compilation or condition is tested at the beginning of the loop before statements allow into a double operation statements. We have seen the for.
Now we will introduce the do-while iteration statements. It is also another type of the iteration statement, same as the for and similar to the for and the while statement.
And the while statements now will then another iteration statements. It is the do-while iteration statements. And the do-while iteration statements is very similar to the while statement. In the while statement, we can remind in the while statement, the loop compilation or condition is tested at the beginning of the loop before the body of the loop is performed. But however, in the do-while statement, it will test the condition after the loop body is performed. And therefore, the loop body will be executed at least once. And when a do-while stops, the executing will continue with the statements after the while condition. And if it is not necessary to use the braces in the do-while statements, which means we can remove or do not use the braces between the do and the while keywords. And however, the braces are usually included to avoid the confusing between the while and the do-while statements. For example, the while statement is usually regarded as the head of two while statements. So a do-while with no braces around a single statement's body will appear as do-while, and which can be confusing. And the last line, the while conditions, may be misinterpreted as a while statement containing an empty statement. So to avoid the confusions, then do-while with one statement is often read as follows. And this figure shows examples of the do-while statement to print the numbers from 1 to 10, and the control variables. The count is pre-incremented in the loop test. It's very similar to the while statement. This figure shows the do-while statement's flowchart, and which makes it clear that the loop conditions does not execute until after the actions is performed at least once.
Yes, because it will first do the statements and then to judge whether the condition is true or false. So for the do-while statement here, it first will execute one action and then judge whether the condition is true or false. If the condition is true, then it will continue and do the action again and then judge the condition again. So no matter the condition is true or false at the beginning, the statements inside the do-while will be executed first.
Clearly that the loop conditions does not execute until after the actions is performed at least once. And this is a break, and the continue statements are used to alert the form of the control. First, the break statements. When executed on a while, for, or do while, or switch statement, we will say the switch statement later, which will give an intermediate execute from that statements, and the program executions will continue with the next statements. And also, the common use of the break statements are to escape the early from a loop or to skip the remainder of the switch statements. And also, we have the continue statements. The continue statements, when executed in a while, for or do while statements, will skip the remaining statements in the body of that control statements and performs the next iterations of the loop. In the while and do while statements, the loop test is evaluated immediately after the continuous statement is executed. However, in the for statements, the increment expressions is executed, and then the loop test is evaluated. This figure demonstrates the break statements here in a for iteration statements. And when the if statement detects that x has become 5 and break is executed, so this will terminate the for statements, and the program will continue with the print after the for, and the loop fully executed only 4 times. Because when the x equals to 5, it will break this loop. So it only executed 4 times.
Do you have any questions for this break statement? The break statement is to break iterations and go out of the loop, go outside. Yes, if no break, then it will print 10 times because x is equal to 5 and then it break the loop. So it go outside of the for loop. So it prints the break out of the loop at x, the last line in this code.
For the print statements.
Yes, the break. In fact, you can remove all the space in a code because we distinguish each statement by this sign here, right? We introduce it at the first lecture, but for the readability, we use a single line for the break statement. And for other statement, we also use a single line.
And this is an example, this figure uses the continuous statements in for statements to skip the print statements and begin the next iterations of the loop. When the x equals to 5, then it will continue to the next loop. So it will skip this print at the line 15. And then the x will be 7, and it will also execute the print statements. So in this case, the value of the 5, or when the x equal to 5, then this print of the value for x will be skipped.
Do you have any questions for the continue statement? Different from the break statement to goes out, to goes out and escapes the following for statement. The continuous statement will escape the remaining part of the for statement at this time, and then it will end the next. It will end the next loop in the for loop. So it just skip this line, print the X. So we can get the answer here. Do you have any questions for this continuous statement? And remember, the continuous statements and the break statements are different. We do not need to type else, right? Why we need to type else here? Because this is a continuous statement, right? When the x equal to 5, then we will execute this statement. We'll execute this statement. This statement is continuous statement. Continuous statements will tell us that skip the following lines and go to the next step in the loop. This is a continuous statement. The print for do not the part of the if statement. Yes, this sign, the n, can be put at any positions of the string, as long as you want to get a new as long as you want to get a new line. We do not need the if else here because this is a if statement, and this line is not a part of the if statement. So remember, use the break to break this loop and use the continue to skip the remaining code in the loop body. And this print4 is not a part for the if statement. This is a reminder statement for the for statement. It's also a part of the body of the for statement, same as the if statement.
We have learned the different types of the iteration statements, and we also have seen some of the single selection if statement.
We have known the break and continuous. They are usually used in the iterations and also will be used in the multiple selection statements. And for the selection statement, we have learned the if and the if else. Now we'll learn the switch. It's another type of the selection statement.
And the double selection, the if else statements. Now we will learn the multiple selection statements, the switch. In fact, algorithm will contain a series of decisions in which a variable or an expression is tested for each of the consistent integer values it may assume, and different actions are taken. And this is called the multiple selection. And the C provides the switch, a multiple selection statement to handle such decision making. And the switch statement will consist of a series of the case labels and optional default case and the statement to execute it for each case. And if no match cases, the default case is executed and an error message is also printed. And it's worth note that we use the break just follow the statements in a case. The reason is that if we need to break the case executed, if the statement has been taken, and if the
now we talk about the break statement in the switch. The break is very important in the switch statement. If we do not use the break statement, then many statements inside the different cases will be executed.
It is not used anywhere in a switch statement. Then each time match cases in the statement, then the statements for all the remaining cases will be executed. For example, if we remove the break, and if the consistent expressions,
if we remove the first break,
case 1 is the true, then we also remove the break. Then the case the statement 1, the statement 2, and the statement n will be executed if we remove the break statement. So remember to include the break statement in the switch, in the case of the switch multiple selection statement. Here are sample examples for the switch statement. We input the grade, we giving the grade of the giving a testing grade, and then depend on the value of the grade, we will print the messages about this grade. So in these cases, we will find that the grade equal to 18 will be true. So we'll print the grade 18, and we'll also include break to execute this switch selections. And if we remove this break, what will happen?
If we remove this break at the line 12, what will happen? What's the result will be printed on the screen? So could you guess the answer? If I remove this line. Yeah, I remove this line. So the case 18 is also true, right? It's still true. So this line is also be printed, right? 子秋. So maybe you can change your answer to include. Yes, I have seen the correct answer from Wen. So if we remove this break, then this line will also be executed, right? And the way it will also execute other statements in the case. In other case, so it will execute this line. And then at this line 15, it will break this switch. So it will output those two lines. Maybe we can see it. Yes, only remove the second break. We can get the answer here. So remember to include the break in the switch statement.
Could you imagine what will happen if we remove this break? This is another switch statement examples. And we are asked to use the switch to count the number of each different later grade students will give on our examinations. And I will type this code in the IDEs and explain each line of this code.
At this time, I will not type this code in IDE, but I will explain this code and explain some important parts in detail. Can you show my example in C program? You mean what example? This one? Because we remove the break here, so it will end the case here. If no break, it will execute the other statements in other cases following. So it will execute this sentence, and then it execute this sentence and break this switch. So we need to add break here to make sure we only perform the statements in case the case is true. Yes, it's not much, but it matches here, right? It ends the statement stages, so it will not judge the case statements anymore. If it achieves the first true, then it will start to perform the statements, and it will not check the case anymore. So it will neglect this line, just performs other statements until this break. It will match the case 18, so it will print this line if we added a break. Because C is 18, right? So it will print this line. We can see. The 18 is showing here. In this case, the 13 is not printed. If we remove this break, then the 13 will be executed. If we, in the switch statements, if a case is true, right? In this situations, the case here is true, right? So it will execute the statements, no matter what's the case the statement belongs to. So it has been true here. So it will execute all the statements, and it will not judge this case anymore. Do not judge the true or false for the remaining cases. Just perform the statements. How the case can read the value of C, because the C are here. So it will compare the value to the C here. It not only judge the case for once, it will judge the case until the case is true. Is it a break behind the switch? You mean this brace? It must include, because this means the body of the switch. Yes, you must include this brace because it's a statement. Okay, we can see these examples. We will go through this code.
QT. So, it student.
First, we will define the counter for different grades, right? The A, B, C, D, and F. And then we will ask the user to enter the grades. And then we also ask the user to enter the end of the file flag a signal to the end input. And then we define the grade, decline the grade, and define it. And where we can loop until the user can type the end of the file key sequence, we will continue this loop. I will explain this now and later. And then we can see the switch statement. In the switch statement, we will compare each case with the grade we read this time. And if the case is true, we will add the grade, the counter for the corresponding grade, and then break this case. And it's also note that we do not have any statements following this case, the letter A here, right? Because there's two A's, their statements are the same. Both those the two cases, the statements is just to add the increase the one for this variable, the counter for the A. So we do not use the break along this case A, because these two cases has the same statements needed to be executed. Also, we judge the case B, the case C, case D, case F. And then we will also skip some new lines, some tables, and some space. If the user enter those, if the user enter the new lines, enter the tables, or enter space, we will ignore them and just neglect them. Also, the other situations will print the user input a wrong letter grade if other cases are input in by the user. Finally, we will print the count for different grades, different types of grades, right? They are not the flag value, which means if because some user maybe you may input 100 grades, and in some case you just type more space or type new lines. You do not want the program just stopped and see that this is a wrong number and a wrong grade. You just skip these situations for more helpful, right? If I print A, B, C, D, and I just print some table or print some new lines due to my carefulness, I do not want the code to stopped due to my carefulness. So these three cases will help the user to skip those three situations. If the user input the new lines, the table, or the space, then no action is performed in this time, and it will continue to rate next grade.
Well, give an example.
Now we will see some important parts of this code, such as this line and the switch statement.
Assignment executes the first get the file header. The assignment executes the first. So the getChar functions from the studio.h header will read the one characters from the keyboard and then returns as an int the characters that the user entered. And the characters are normally stored in a variables of the type chart. So, however, an important feature of C is that the characters can be stored in any integer type data type because they are usually represented as a 1 byte integers in the computers. They are the ASCII code. So the assignment as a whole actually have a value here. And this value is assigned to the variables to the left side of this assignment sign. And this value of the assignment expression is the grade be assigned as the getChar functions is compiled with the value of the EOF, which is the end of the file, and a sample who stands for the end of the file. And we use the EOF, which normally has a value the -1 as a sentinel value and a flag value. And the user will type a system-dependent key token combinations to mean the end of the file, which means that I have no more date to end. And then the EOF which be defined in the studio.h header. If the value assigned to the grade is equal to EOF, and then the program will stop. And we have chosen to represent the characters in this program as ints because the EOF has an integer value, and they are normally the -1. Also, the key source compilations for int EOF are system dependent. So the sentence will read the characters from the user until end of the input. And this is a body of the while statements. And we will look.
Do you have any questions for this input statement? And the value of the EOF is given by the head studio standard input and output header. And you do not understand which part of this statement. This function, this getChar function, is a function given in this header. So you can just use these functions. And these functions will read characters from the keyboard. Yes. In this case, there is no parameters in these functions. We will introduce the parameters and the functions in next lecture. The get char is a functions, and we will introduce the functions in next lectures. And there is no anything there between those two braces is because there is no parameters for this function. Yes, it read a character, right? Read a character, then assign the value of the character to the grade. So if we just look at this part, it will get a character and then assign the value of the character to the grade, right? So the left part, yes, this part, is finally a grade which with the value of the characters from the user. And then we will compare this grade, these characters, with the EOF. If it's not equal to EOF, then we will continue our while statement. And what is the EOF? EOF is a flag, which means that end of the input, end of the file. What equal to EOF? The grade not equal to EOF. Yes, this is a brace, right? So this is the whole expressions here. And the value of the expressions will be the value of the grade, because the value of the expressions will be the value of the grade because it's an assignment operator we introduced at the last part of the lecture, of the last lecture. The value of the expressions is the value of the grade. So this left part, this whole part, its value is a grade. And then we compile the value of the grade with the EOF. Same as we compare the counter is less or equal to 10, same as before. You can imagine that the EOF is a flag. Yes, it will read. Yes, it compiles. It will read the characters and compile the characters with a flag, and the flag, the signal is a EOF. Just write them in a single line. However, there are some difference for the scanful function and the getChar functions, because these functions it will return a value to a grade, and we will talk about the functions for in the next lecture. Just now, you do not need to know more details or know more about the function. You just need to know that these functions will return a value to grade, and this value is a character. So do you have any questions for this statement? No. The user will enter a character, and then the character will be assigned to a grade. And then we will compile the value of the grade. We not just compile the grade, we compile the value of the grade, because we need to compile the expressions. And the value of the expressions is the value of the grade. We will compare the value of the expressions, which is the value of the grade, to the EOF. And the EOF is a flag, is a signal. Do you have further questions for this statement? Zhiqiu lists the 3 steps, and missed one step is that we need to compare the value of the expressions, those left expressions, to the EOF. And the expressions, the value of these expressions is equal to the value of the grade, because the assignment operator. Your understanding is somehow correct, but not very accurate. So, do you understand this line, this statement? Can we move on? No, I will not introduce the EOF in the next slide. The EOF is just a flag. It's just a signal, like the -1, and it usually has a value of the -1. And it is defined in the studio, the standard input and output header. You can use it as a flag, just use it as a flag, a signal. And this keyword has been defined by the other part, by the part of this file.
The characters from the user entity.
The EOF not always equal to -1, but it's usually the -1, and it depends on different system. For example, the control D means the EOF in the Mac OS system, and I remember the control Ray means the EOF for the Windows system.
End of the input. And this is the body of the while statement. And we will look at this. First, the keywords, the switch.
Sorry, this is the body of the switch statement.
Followed by the variable name, the grade, in this parentheses. And this is called the controlling expressions. And the value of these expressions is compiled with each of the case labels. And I assume the user has entered the late C as a grade. Then the C is automatically compiled to each of the case in the switch. And if a match appears, which means this case C, the statements for that case are executed. And in the case of the late C, the C counter is incremented by the 1, and the switch statement is executed immediately with the break statements. And the break statements causes the program control to continue with the first statement after the switch statements. And the break statement is used because the cases in a switch statement would otherwise run together. And so, if the break is not used anywhere in a switch statement, then each time a match will appear in the statement, and the statements for all the remaining cases will be executed. This is called the for source. And if no matches occurs, then the default case is executed, and the error message is printed. And each case can have the one or more actions. And the switch statements is different from all the control statements in that the braces are not required around the multiple actions in a case of the switch. And the general switch multiple selection statements is flowcharted in this figure. And this flowchart makes it clear that each break statement at the end of a case will use its control to immediately execute the switch statement. So far, we have learned the different operators, and here I list the precedents and the associated for those operators. And in this lecture, we add the common operators here, the last row. And the associated from the common operators is from the left to right. We have seen it before. It will first execute the left expressions and then the right expressions. And the value of the expressions will be the value of the rightmost expressions. Here, summary, we in total has learned some different structured programming technologies. And the left figure summarize the control statements discussed in those two lectures. And they are the sequence statement, the if statement, the if else statements, and the switch statements. And the small cycles are used in a figure to indicate the single entry point and the single execute point of each statement. And collecting those individual float-chart samples can be lead to the unstructured programs. And also the right part of this figure summarize the loop, the interaction statements we learned. They are the while statement, the do while statement, and the for statements. In fact, we can form the complex structured programs from the simple programs. And the programmers had chosen to compile the flowchart samples to form a limited set of the control statements and to build only structured programs by compiling the control statements into simple ways. And so simplified, we only use a single enter and the single return control statements are used here. And there are only one way to enter and only one way to return each control statement. And collecting the control statements in sequence to form the structured program is simple. And the return point of one control statement is collected directly to the end point of the next. And which means that the control statement are simplified placed on one after another in a program. And we have called this the control statement staking. And the first rule is that we can begin with the simplest flowchart as shown in this most left figures, most left flowchart in the slides. And the second is that we can staking, which means the staking ruler, which means that any actions can be replaced by the two actions in sequence. And repeatedly applying the ruler 2 to the simplest flowchart here results in a structured flowchart containing many actions in sequence. They are showing here. And the ruler 2 can generate a stake of a control statement. So we call a ruler 2 as a staking ruler. And also the ruler 3 is that listing ruler, which means that any actions can be replaced by any control statements. And we repeatedly apply the ruler 3 to the simplest flowchart results in a flowchart with a listed control statements. For example, in this figure, these actions in the simplest flowchart is first replaced with a double selection, the if-else statements. And then the ruler 3 is applied again to both the actions in the double selection statements, replacing each of those actions with the double selection statements. So the dash box around each of the double selection statements represents the actions that was replaced in the original flowchart. And also, the rule 3 and 4, rule 2 and 3 can be applied as often as you like and in any orders to form more complex structured programs. And in these two lectures, we learn different program controls and the structured. And 4, rule 2 and 3 can be applied as often as you like and in any orders to form more complex structured programs. And in these two lectures, we learn different program controls and the structured programming, and it mainly consists of three different types of the controls. They are sequence, the selection, and the iteration. First, the sequence is a straightforward statement. It executed step by step. And the second is the selection. The selection is implemented in one of the three ways: the if statement, the single state selection, and the if else statement, the double selections, and the switch statement, the multiple selections. And in fact, it's straightforward to provide that the simple if statement is suitable to provide any forms of the selections. And everything that can be done with the if-else statement and the switch statement can be implemented with one or more if statements. And finally, is the iteration statement. The iteration is implemented in one of the three ways: the while statement, the do-while statement, and the for statement. And it's straightforward to provide that the while statement is suitable and is enough to provide any form of the iterations. And everything that can be done with the do while statement and the for statement can be done with the while statement. And compiling those results will show that any forms of the control ever needed in a C program can be expressed in terms of only the three forms of controls. They are the sequence, the if statements, and the while statements. And those control statements can be compiled in only two ways: the staking and the listing. So indeed, structured programming promotes simplicity.
So we have learned the structured programming, the program control in these two lectures. Do you have any questions for these two lectures and for the program control and the structured programming? The example of the listing rulers
which means the state
is here.
In the double.
For example, this is a simplest case, right? And in these examples, we will replace these actions as two if actions. We will replace these actions as an if statement to perform two different actions. Here, the if statement is a case for the listing rulers. For example, at the beginning, we just learn the sequence structure, right? And then we remove a 9 in the sequence structures and replace it by a if statement. Then this is a listing. Do you have more questions for these 2 lectures? It is better to rewrite the codes at the lectures and the tutorials by yourself and without see the results and the examples and the code in the lecture and the tutorials, and write and solve this problems by yourself. And the practice is very important to learn the programming. Do you have any questions? So you are suggested to write those code to solve the problem by yourself. And also you can propose some problems by yourself and you try to solve it using the C code. In the next lecture, we will start to introduce the function, which is an important part and a feature for the programming. And also we have released the first assignment on the blackboard. So please check and complete the assignment on time. If you have no more questions, maybe we stop here. This is 22 in this month. And also the assignment and the due dates are all listed in the schedule table, which is given at the first lecture. 24. And the schedules and the rulers to submit the assignment are also given in the first lecture. So if you have no more questions, maybe we can stop here. And remember to write the code by yourself to learn the programming. And the assignment also includes some programming questions. Okay, we end here.